All right, so we just got done adding and subtracting polynomials. Now we're going to start multiplying them. We're going to start out with monomials, which are just the things with one term, like that and like that. So multiplying monomials. So we really have two parts. First, when you want to multiply those, you multiply the numbers. Really, by that I mean the coefficients. In the first example, example 1, would be multiplying 3 and 4. The second thing that you do then is multiply the variables. So we'll do several examples, and that'll kind of help. But first, for this one, say multiply the numbers. We mean, all right, we have a 3, we have a 4. We multiply those, and we get a 12. Then we multiply the variables. We have a x, or an x to the first, and we have an x squared. So we take multiplying x times x squared. You add the exponents together, which gives us a x to the third. And that would be the final answer, 12x to the third. We could do the same thing here for example 2. We multiply the numbers. So I have an 8 for a coefficient and a 1/2. So 8 times 1/2 gives me a 4. Now we multiply the variables. So we have two different variables here. We have an x. So here we have an x to the first and an x to the third, which gives us an x to the fourth. And that x to the first over here might mess some people up. Some people see that 2 and they think, oh, it's an x squared, y squared, but the 2 just applies to the variable before it. All right, so we have x to the fourth. Now we have a y squared, and we have another y squared, which then would give us a y to the fourth. Do the 2 plus 2. And that would be our final answer. All right, this next one, it's a little different that I have 3 monomials, but we do the same exact thing. We multiply the numbers. 4 times 3, and technically there's a 1 right there. You could say a 1x. And that just gives me a 12 for the coefficient. Then we do our variables. I have an x to the first times an x squared times an x to the first. So I do 1 plus 2 plus 1 gives me an x to the fourth. All right, so nothing real special about the two different colors, just trying to show how it relates to the thing above. Multiply the numbers and multiply the variables. All right, so now if we have one or more polynomials, so before we just had single terms, now we're going to have like possibly binomials, like this example here. A monomial times a binomial, or a monomial times a, I don't know, it's a 4-term polynomial. So for this, each term or clump in one must be multiplied by every term in the other. By every term. And those terms are really just like the little clumps in there. So by every term in the other. And really it's just the distributive property that we looked at before. So that's what I wrote here. I wrote distribute each term in one by every term in the other. So if we take something like this, I wouldn't write this, I'm just trying to make a point, but something we have been doing for a while would maybe be like a 3 times x plus 5 or something like that. And we would just do a distributive. You do 3 times x times plus 3 times the positive 5. We do the same exact thing when we do a monomial times a polynomial multiplication. Here I have my 3 times my 4x squared. So if you go back to that's kind of like what we were doing up above in Roman numeral 1, 2 monomials. So we do the 3 times 4, which gives me a 12. And then we don't have anything to multiply by the x squared, so it's just an x squared. And then we do the 3 times that second term in the parentheses, which is another monomial times monomial. So I have a positive 3 times a positive 8, gives me a positive 24. And then I have, you could maybe say a 1 times x times y or something, but anyways, you just get that there. 12x squared plus 24xy. Next one, we do the same exact steps, there's just more of them. So I have my 8x squared times my 2x to the third. So again, you could treat that like what we did up above with a monomial times a monomial. And I do a 8 times 2 then, gives me a 16. And x squared times x to the third is x to the fifth. I add those exponents. All right, next we do my 8x squared times the second term right there. So a positive 8 times a negative 5 gives me a negative 40. x squared times x squared gives me x to the fourth. I'm adding those exponents together. All right, now we repeat the same sort of thing with the next term. So I have a positive 8 times a positive 4 gives me a positive 32. X squared times a x to the first is a x to the third. And then last but not least, I have my 8x squared times my negative 3. So 8 times negative 3 gives me a negative 24. And then I have my x squared. There's nothing really to multiply it by, so it just shows up over there. And that'd be the final answer. You could look, is it in standard form? And as long as this here starts out in standard form, our answer will be 2. So we have the highest exponent first, the x to the fifth term in first place, then x to the fourth, x to the third, x squared. Just kind of going in order from biggest to smallest. All right, we successfully did page 1 of the notes. So if we jump down here, polynomial times polynomial. Really, this is what we just did, but we do it twice. And then look, is there things we can combine? And we really go back to this first term, these instructions we have here. You multiply each term or each clump in one must be multiplied by every term in the other. So how that applies then down here is just like before, we did this x here times each of the clumps, or each term, I really should say there. We would do those 3 first, and then we go back and we do the same sort of thing, but with that positive 2. We do a positive 2 times each of those. So a lot of this is really just staying organized and not messing up. But okay, so I have my x times my 3x squared. That gives me a 3, because it's kind of like a 1x, so 1 times 3 is 3. And then x times x squared is x to the third. And then I do my x times my negative 5x. So 1 times negative 5 is negative 5. X times x is x squared. All right, then I'm going to do my x times my positive y squared. So for coefficients, it's kind of like a 1x and a 1y, so it's just a 1 or just plus. Then I have my x y squared. We'll always write the variables alphabetically so that it'll be x times y squared, not y squared times x. All right, so we have that. Now we are halfway done with the multiplying part. So I'm going to do those same sort of things, but I'm going to start with the 2. So I have a positive 2 times a positive 3x squared. So that gives me a positive 6x squared. 2 times 3, and I have my x squared. All right, then I'm going to do my positive 2 times my minus 5x. Gives me a minus 10x. And then last but not least, I have my positive 2 times my positive y squared, so plus 2y squared. Now, let's see if there's anything we can combine, and it looks like there is. I have 2 things that are this x squared. So let's maybe just kind of start writing them, and I'm going to start with kind of going standard form. So you have this 3x to the third. So I'm going to say 3x to the third. Oops, I'm going to do that in black. So 3x to the third. Sometimes it's easy to miss stuff, so often I'll go through and kind of underline stuff. I've seen students that cross things out when they use it. I have my 3x to the third. Next I have my x squared. So I have this minus 5x squared plus 6x squared. So I have negative 5 of them plus 6, which just gives me a positive 1. So just a plus x squared. I could write a 1x squared, but then it's not simplified, so I'm going to leave the 1 out. All right. Now I have, it's a little bit of a toss-up which one we do. I'm going to do this one here next and say minus 10x. And then start jumping over the things that have the y's in it. So I have then a plus xy squared. And last but not least, a plus 2y squared. So I chose to start alphabetically with x. I have x to the highest power, x to the next highest, x to the first, then the x that has the y with it, And finally, the thing with no x's, but just the y's. That's kind of the method of the madness there. All right, next one. We'll just kind of go through and do it in a similar way. So I'm going to start and say I have my 3x squared times x to the third. So 3 times 1 is 3. X squared times x to the third is x to the fifth. Then I have 3x squared times a negative 5x squared. So positive 3 times negative 5 gives me minus 15, or negative 15. That'll be an x to the fourth. Then positive 3x squared times positive 3x gives me positive 9x to the third. And then last but not least with this first one, I have a positive 3x squared times a negative 7. So positive 3 times negative 7 is minus 21, or negative 21. And I have an x squared. So we're halfway done with the multiplying, and I'll erase those. And then we'll jump over here and do the same thing with this minus x. So it's like I have a negative 1x times all of those. So negative 1 times positive 1 is minus 1. X times x to the third is x to the fourth. And negative 1x times negative 5x squared. So negative 1 times negative 5 gives me a positive 5x to the third. And then negative 1x times positive 3 is minus 3x squared. And last we have the negative 1x times a negative 7 gives me a positive 7x. Okay, so we have all that. Now we just go back and collect like terms. So I'm seeing over here I have an x to the fifth. That's my only x to the fifth. So I'm going to say, all right, I have 3x to the fifth. And underline it to show that I have that one done. All right, next ones, I have 2 that are x to the fourth. So I have negative 15 of them, then another negative x to the fourth, or negative 1. So that gives me a total of negative 16 of these x to the fourths. All right, now I'm going to jump over to my x to the third. So I have positive 9 of them, plus 5 more of them. So 9 of them plus 5 more gives me 14. So plus 14 of my x to the thirds. And we're getting close to the end. If I say next x squared, I have a minus 21 of my x squareds. Minus 3 more of them, give me minus 24 x squareds. And then our little tag along here at the end, plus 7x. So really the problem, hopefully you see each step isn't necessarily hard as much as there's just a lot of steps. So being organized, being neat, showing your work, it can really make a difference. So binomial times binomial. This here you can treat just like what we did up above, but there's kind of a special way that's really going to more help us in a future chapter when we get into factoring, but it's a shortcut for this too, I suppose. So we could distribute like we do any polynomial pair. And by that, I'm saying, well, we could do x times x. That gives me a x squared. Then we could do the x times the negative 5, which gives me a negative 5x. And then we could do the positive 2 times x. So instead of doing all my lines up on top, I'm going to do a couple down below just to make it look a little neater. So plus 2x. And then we could do the positive 2 times the last clump and give me a negative 10. And when we do that, I kind of want to look at what are those 4 different things that we did. Well, that gets into what I have written here. One way to remember this special case. If you look at what I did, the first thing I did here with my green was I did the x times, oh no, the blue, or the aqua thing. I did x times x. So this right here came from multiplying the 2 firsts together. So the first one of the first times the first. This green, my minus 5x, came from doing the x times the minus 5. So they'll call that the outside. So my next one is a O, if I'm going to write for outside. And then this plus 2x came from doing my positive 2 times my x. So we're going to call that in blue the inside. And then last but not least, oh, looks like I did the same color for the two last ones. Oh well. So I have positive 2 times a negative 5, give me this one here. So I did the last one times the last one. So we'll put that down as a L for last. So in other words, one way to remember the special case is FOIL. So FOIL. And what that stands for is first, so we multiply the two first ones together, then the outside, and then we did the inside, and then we did the last. So you might not see how this is a huge shortcut right now necessarily, but it's going to start coming in handy in the future. So when we do this FOIL thing, we have a binomial times a binomial. The inside, outside, and inside, the middle two can be combined. So I just have an x squared here, minus 5x plus 2x gives me minus 3x's. So that would be the outside and inside together. And the last is my minus 10. So that there would be my final answer on that one. So that should be covering these 4 learning targets. You can multiply monomials, that was Roman numeral 1, multiply polynomials, that's Roman numeral 2, and then over here in letter C, we got to what FOIL stands for, so the first, outside, inside, last, and you can FOIL 2 binomials, that would be the last example. So that's it for this section, kind of a long one. Have fun. Let me know if you have questions.